Welcome back to question 2, everyone, where we learn how to solve kinematic motion in 1D type of problems. This time the question reads, two vehicles are at position x is equal to 0 and t is equal to 0. Vehicle 1 is moving at a constant velocity of 30 meters per second. Vehicle 2, starting from rest, has an acceleration of 10 meters per second squared. Where do they pass? To answer this type of problem, we can think of this algebraically. We are looking for when the final x value is the same. So for the first car, we're told that it has a constant velocity of 30 meters per second. And by multiplying the velocity by the time, you actually get the position. So let me just write that down, that the position of the first vehicle is x is equal to the velocity times the time. So v times t. The velocity for the first vehicle is 30 meters per second. And if we happen to know what t was, we can just multiply it and we'll get x. But we don't know what t is, so we'll just leave it blank. And for simplicity's sake, I'll remove m over s so that we don't get into any confusion. Now for the other car, we are told its acceleration. And the formula here that relates the acceleration, time, and velocity is this one. So let's see if we can use that for the purpose of this example. We are looking for x, and we know x sub 0 is 0 because they start at rest. They start at a position of x is equal to 0. So I'll have x minus 0 is x. And on the right side, the velocity initially for vehicle 2 is assumed to be 0 because it's starting from rest. So the initial velocity is 0 times time. That eliminates this part, and we're left with half times the acceleration, 10 meters per second squared. And again, we don't know the time, t squared. What we can do now is solve for t in this equation and substitute its content into here so we can isolate for x. In case you're confused, here's what I mean. I'll divide both sides of this equation by 30, and we're left with x over 30 is equal to t, and I'll substitute that right there. X is equal to half times, and I'll ignore the units because it will cause confusion for us, 10 times x over 30 squared. This is not hard to do. We need to solve for x. We have an x term here and an x term here, so let's expand this out a little bit more. Half times 10 is 5, and if we want to distribute this exponent of 2 to this fraction, we give it to the top and to the bottom. So I have x squared over 30 to the power of 2 is 900. Furthermore, 5 over 900, that can be reduced. 5 over 900 is 1 over 180. So I have x squared over 180. No need to write down the coefficient of 1 up here. That's just redundant. We have an x on the left side and x on the right side. So if I divide both sides by x, this x and that x will cancel out, leaving us with 1 is equal to, and one of these x's at the very top, and this one will cancel out, leaving us with x over 180. We have one more thing to do, multiply both sides by 180, and we end up with our x value. So they will meet each other at 180 meters, given the information. In part 2, when do the vehicles have the same velocity? The best way to approach this problem is to use this formula. And we want to assume that vehicle 2 at some point will reach a constant velocity of 30 meters per second, which is what vehicle 1 is experiencing. So using this formula, I'll write down, assuming that vehicle 2 reaches 30 meters per second, I'll write 30 meters per second as its final velocity, and that's equal to its initial velocity of 0, which we determined is 0 in the previous example, plus its acceleration of 10 meters per second squared times t. If I solve for t, I will end up with the time, and I can use that then to find the time that relates the first vehicle. So first let's solve for t, divide both sides by 10. We should end up with 30 divided by 10 is 3 seconds. 3 seconds that the second vehicle will reach 30 meters per second. So this one right here represents when the vehicles have the same velocity, 3 seconds. Before I answer this, if I wanted to find the position right now of both vehicles, I would take the 3 seconds here, multiply it by its velocity of 30 meters per second, and that would be 90 meters away. So going to this question, what are the position, velocity, and acceleration of each vehicle when vehicle 2 has traveled twice the distance of vehicle 1? So what we can say for the position is that the position of vehicle 2, the final position, which I'll write as x sub 2, its final position, is 2 times that of x sub 1. For this part, I'll replace that with the relationship found here, where x sub 2, let's pretend that's x sub 2, that's for the final position of the second vehicle, is equal to half the acceleration, which was 10 meters per second squared, t squared. I'll replace this expression right into here. I've made some more room up here just for convenience sake. So 5 meters per second squared times t to the power of 2. That's this part. And for this part, 2 times the expression that we used earlier. Remember that the position is equal to the speed or velocity times the time. And that being said, I'll replace the x sub 1 with v times t, and we know that constant speed was 30 t. So this adds up to 60 t, and that is 5 t squared. Notice that I'm ignoring the units. Let's solve for t. I'll bring that over. T squared minus 60t is equal to 0. Isolate for t by factoring it out, and the 5. This gives us t minus 12 is equal to 0. We'll have two t values. T is equal to 0 and t is equal to 12. So I found out what the t's were here. I'm going to ignore t is equal to 0 because it doesn't really make sense that time is equal to 0 right at the very beginning. It's double the speed. And I'll concentrate only on t is equal to 12. So using the original statements from A, I apologize for all the mess here. The original statement for A was x is equal to the velocity of 30 meters per second times the time of 12. If we multiply that out, we get 360 meters. This represents the position of vehicle 1, and the velocity of vehicle 1, since it's constant, is still 30 meters per second, and the acceleration of vehicle 1 will be 0 because it's constant velocity. For vehicle 2, we'll take its acceleration, meters per second, and multiply it by the time, which we found was 12. This multiplies to 120 meters per second. That's the velocity of vehicle 2. The acceleration will be the same. It's 10 meters per second squared, and the distance will be double that of the vehicle 1. And using this statement, it's going to be 720. So whatever that was, 360, we multiply it by 2, and we get 720. So that was x sub 2, or the final position of the vehicle 2 is 720. And there you have it. That is how to solve another kinematic motion in 1D problem.